Math 082 Practice Final Review Problems 68, 69, 70, and 71. We are going to reduce this rational expression. We must be aware that there are two types of numbers: coefficients, like 16 and -8, and exponents, like 11, 5, 8, and 2. We will deal differently with coefficients than we will with exponents. The coefficients we are going to reduce like a normal everyday fraction. 16 and 8 can both be divided by 8. 2 and 1, with that negative sign, that's actually a -1. But for exponents, in a division problem, the shortcut is to subtract. We are going to find the greater exponent, which is 11, and subtract the lesser exponent, which is 8. Since the greater is in the numerator, the one we began the subtraction, 11 minus 8, with, our answer goes in the numerator. Y to the fifth divided by y to the second. Again, the shortcut is to subtract. We will find the greater exponent, 5, subtract the lesser, 2. We begin our subtraction with the exponent in the numerator. Our answer goes in the numerator. Now 2 divided by -1 is -2. We no longer have a denominator. 11 minus 8 is 3, so we have x to the third. 5 minus 2 is 3, we have y to the third. Let's check our answer. Let's move to problem 69. Let's deal with the coefficients first. -60 divided by 15, that's -4. X to the 13th divided by x to the 9. In a division problem, we subtract exponents. The larger exponent is 13, so we will do 13 minus 9. Since we begin our subtraction with the factor whose exponent is in the numerator, the x to the 13th is in the numerator, we put our answer where a numerator would be, that's on top. X to the 13 minus 9. Y to the fourth divided by y to the third. Subtract exponents. 4 minus 3, we begin with a 4, that's in the numerator. We put our answer in the numerator, and there's still no denominator yet. T to the fifth divided by t. We note this is t to the first power. Greater exponents in the numerator, so we begin our subtraction. 5 minus 1, our answer goes in the numerator, because we began our subtraction with the factor whose exponent is in the numerator. So we have -4, x to the fourth power, y to the first power, t to the fourth power. And this first power can be dropped in our final answer. -4, x to the fourth, y, t to the fourth. Let's check the answer key. Problem 70. We begin with the coefficients. 15 divided by 60. We can reduce those. Both numbers are divisible by 15. -15 divided by 15 is -1. 60 divided by 15 is 4. In the denominator we have 4, in the numerator we have -1. X to the 9th divided by x to the 13th. Our strategy has been to find the larger exponent, 13. We will do 13 minus 9. Since we begin with the x to the 13th in our subtraction of 13 minus 9, we put our answer in the denominator where the x to the 13th is. X to the 13 minus 9. Y to the third divided by y to the fourth. Again, we will subtract 4 minus 3. Since we're beginning with the y to the fourth, we put our answer in the denominator as well. T divided by t to the fifth. We will take the exponent 5 minus the exponent 1. Since we're beginning with the factor in the denominator, subtracting 5 minus 1, put our answer in the denominator, t to the 5 minus 1. The -1 in the numerator cannot be dropped. The denominator is 4, x to the fourth, y to the first, t to the fourth. This exponent 1 can be dropped. Here is our final answer. We will check it. Problem 71. We begin by reducing the coefficients. 8 divided by 4, that's 2. That goes in the numerator. Now we must divide y to the negative 3 by y to the negative 5th. Our strategy has been to find the greater exponent, subtract the lesser. Negative 3 is greater than negative 5, so we will compute negative 3 minus negative 5. Since we are beginning with y to the negative third in our subtraction of exponents, our answer goes where the y to the negative third is, and that's in the numerator. So y to the negative third minus, that's the shortcut for division, negative 5, which is the exponent in the denominator. Recall that subtraction of a negative is equivalent to addition. We have 2 times y to the negative 3 plus 5. That is 2y to the second power, or 2y squared. Let's check that.